GameSci.com. GameSci.com.
What's up? Welcome to the lesson on Python functions. Python functions is where we learn to break large problems into small problems. The whole idea behind computer programming is whenever you're presented with a big problem, you need to break it up into smaller pieces. We learned this from math class. A large algebraic problem needs to be broken up into several phrases in order to best solve that problem. Same thing for computer programming. Once your code starts getting bigger and larger, it's got to be broken up into smaller chunks, and those smaller chunks are called functions. Here is a function. I've boxed it out for you. The important thing to understand about functions is the need to indent. We're going to define this function, and the body of the function is defined by the indentation after the first line. You have to indent, indent, indent to define a function. In order to understand functions, you have to learn a set of terms that describe functions. Now down below you'll see a set of terms: define, body, call, argument, parameter. We will go through each and every one of these terms, but as we are boxing the term down here, we'll box out the corresponding thing up above when we're actually writing the function. So let's start with the term define. In order to create a function, you have to define or write the function. The first step is this first line that starts with DEF. DEF is literally short for define. I'm defining any function. This box or this line is the definition or the define of this function. The body of the function. The body of the function is the indented code underneath the defined. This is the body of any function right here. If it's indented and all indented the same amount, it is part of the function. As soon as the indent stops, the function stops. Everything indented below the function define is part of the function. That is the body of the function. Next up is the call to the function. We need to call a function in order for that code to execute. Python does not automatically execute a function. It waits for the code to call the function for you. The call to the function is defined right above in the red box. This is the call to the function. It says at this point in the code, I want to stop executing what I'm executing, jump up and run or execute the function. An argument to a function. An argument to a function is a value passed to the function in order that it may do its job. The value 27 is passed to the function as an argument, so the function uses that as input. Parameter to a function. The parameter is the variable name listed here in the parentheses of the function define line. When you're defining the function, you also list its parameters in its parentheses. So in this case, parm1 is the parameter. Try not to confuse it with the argument. The argument was 27. The parameter is parm1. Both of these indicate input to the function. This is how we send input into a function. Return type. The return type is the type of variable or type of value that is sent back from the function. In this case, we're returning 0. 0 is an integer, so this function returns a type int or integer. The return type is slightly different than the return value. The return value in this case is 0. Now 0 happens to be of type int, so the return value is 0 and the return type is integer. As we go through these slides, we'll constantly point out and remind you of these terms. While we're at it, let's go ahead and run this code and see how it works. This, of course, is the call to the function. I'm going to call any function. Right here is the call to any function. I will pass it the argument 27, and it will be set to the parameter parm1. And underneath the cover, unbeknownst to you, Python will assign the argument value 27 to parm1. You don't see this line of code executing, but it certainly does execute. 27, the argument, is assigned to the parameter parm1. Once we're in the function, we will execute the indented code that makes up the body of the function. If there were one line of code here, it'd be one line that executes. If there were 10 lines of code in the function, it would execute 10 lines of code. At the end, we will return something from the function. Now, not all functions have to return a value, but this one does. So it will return a value of type int that contains 0, and it gets sent back to the caller. Remember down below where we called the function? When the function is done and it returns a value, it gets sent back to the caller. See the equal sign there? We want to take whatever is returned and assign it to return value. And the 0 that was returned is assigned to the variable return value. You can see that the 0 that the function returned gets assigned to return value, and then over here you can see return value now contains the 0 sent back. That's our introduction to functions. In the next few slides, we'll learn a lot more about functions. Python functions. Let's go a little deeper into why we write Python functions. One big reason for writing functions is to write once and use many times. Rather than repeating the same code over and over, or even worse, copying and pasting the same code over and over, a function allows us to write the code once and call it or use it for many different parts of the program. Let's write or define a function named updateScreen. We'll use this many different places in our code to update the player's score and the player's health on the screen. Keep in mind the terms we learned in the last slide. What part of this is the function define? Well, that's easy. It's the one that starts with DEF. DEF is literally short for define. This line of code defines the function. What about the function body? What part of this is the function body? That's easy too. It's the indented code underneath the function define. And what is the function call? The function calls are down here below. There's 1, 2, 3 function calls to update screen. Make sure that you understand the parts of writing a function. Learn the vocabulary, learn the terms, and it'll be much easier to understand. Let's start executing some code and see how it works. Let's call updateScreen for the first time. We'll pass it the arguments 0 and 100, and you can see that the 0 gets passed to the parameter pscore. Pscore equals 0. You can see the argument 100 gets passed to the parameter phealth, and phealth equals 100. You'll see it over here in RAM memory. The values of my parameters have been set to 0 and 100. The values of the arguments get assigned to the parameters. This is the call to the function. It says stop what I'm doing and go execute updateScreen. During the execution of updateScreen, it's pretty easy. Output or show the user their score and health values. So this simple print statement will output to the screen a score and a health value. And that's all it is. In a video game, you would expect that you would be updating the screen constantly. When the score changes, you update the screen. When the health changes, you update the screen. This is going to happen over and over and over again. You don't want to copy and paste this code 1,000 times. You'd rather write it in one function and then just call the function. As soon as the function is done updating the screen, what happens? Well, I drew a little red line here to indicate what? The end of the function. The indentation has stopped, so the function is done. When the function is done, what does it do? When the function is done, it returns to the line of code after the call to update screen. So we started here, we jumped to the function, we ran the function, and then we jumped back to the line after the call to update screen. Now here's something interesting. When you're done with the function, the parameters essentially go away. Now I didn't want to disappear them because I'm going to need them for the next call, but pscore and phealth are basically what we call local variables, and as we know about local variables, they disappear when the function is done. So whatever values were in there before, they're gone, and we come back to the main program. We set up a couple of variables here, score and health. We'll set score equal to 20 and health equal to 72. These will be new values that we pass to the function. Here's another call to update screen. Go back to the top where it says write once, use many times. There are many places in my code where I want to update the score and the health of the screen. Every time I do it, rather than copying and pasting code, I'd rather call a function. Now what's different on this function call? Well, there's a big difference. We're sending variables as arguments as opposed to hard-coded 0 and 100. See this 0 and 100? That might work on the first call at the very beginning of the game where everybody knows you start with a score of 0 and a health of 100. But as the game continues, you'll use variables to track score and health, and we want to pass the values in the variables. So the argument ends up being the value of score, which is 20, and the value of health, which is 72. There they are over there. And what happens when you pass the arguments is P score gets set to the value of score, which is 20, and P health gets set to the value of health, which is 72. This assignment here is automatic. You don't do this. Python does it for you when the function is called. With these values in our parameters, P-score and P-health, 20 and 72, when we output this time, we'll see a new updated score and health value on the screen. When the function is done, it's time to return to after the call to the function. I drew this little red line here. Why? Because that's where the indentation stops. The function body is the indented code. Only the code that's indented will execute. When the indented code stops, the function is done and it returns, and you follow this line, it will return to after the call to update screen. Let's do a third call to update screen. This time let's tweak the arguments a little bit. The point I'm trying to make here is the arguments is defined whatever you put in the call. So score plus 10 will take 20 out of the score variable, add 10 to it, and pass 30 as the argument to update screen. Health, which is 72, subtract 4 is 68. 68 becomes the argument to the function. If you look over here, underneath the covers, what does Python do? It sets the P-score equal to the argument 30. It sets P-health equal to the argument 68. And you can see the new values show up in my parameters. When, of course, this runs, what happens? It reports whatever the argument to the function was. P-score gets printed as 30, P-health gets printed as 68, and we've updated the screen again. Think about a video game. How often do you see the score or the health value change? This could be called 1,000 times from 1,000 different parts of a computer program. You write one function once and use it to update the screen many times whenever the score or the health changes. When the function is done, we of course return to the code after the call to update screen. If you follow this line, we will be done with this particular piece of code. Now, why is functions so important? Functions are important because it's so much easier to maintain the code. When you write once and use many times, you can make changes quickly and easy. To show you how easy it is to update, let's switch the language to Spanish. In that case, we can change one function to Spanish, not 100 lines of code that called update screen. Notice all these calls to update screen don't have to change. I'd much rather change one function. So I went on to Google Languages, and apparently score is punctuation, right? And health is salud. So I changed the words score and health to the Spanish versions of score and health. And look, one simple change, and all of a sudden the output to the screen is in Spanish. If I took all my screen outputs and put them in some small functions, those are the only things I have to change the language of my program. Writing the code once and using it many times allows you to make simple updates that make radical changes to your entire program. If that wasn't enough, let's switch the language to French. We want to sell this game in the French market, in the Spanish market, in the English-speaking market. If I sort of corral or segregate all my outputs into a small set of functions that update the screen, then I only have to update that small set of functions. Score becomes le score. That seems kind of obvious to me. The health in French, according to Google Language, is santé. Santé? Who knows? I'm not a French teacher. Anyway, I want to switch the language to French. I have to change one function, not 100 lines of code that update the screen with the health and score. And there you see it on the output. The score and health get updated for the French language. It is so much easier to maintain and improve your code when you break your code up into small functions. If I had printed the word health and score from 100 different places in my program, to change the language, I'd have to go change those 100 different places. By isolating my screen updates to a small set of functions, it's easy to change the screen and change the language on the screen. There's our second example of writing a function, and hopefully you'll take this to heart that it's good programming practice to break your code up into a set of small functions rather than trying to jam a bunch of code into one big giant function. Parameters and return value. Parameters are essentially input to a function. That's why I wrote the word input underneath parameters here. Parameters are input to the functions, and I drew a line underneath the parameters here in the function definition line. I also underlined the argument sent to the parameters here in the call to calc damage. Parameters are an important part of functions. They allow one function to perform many different tasks. They allow us to use this function in many more places in the code. Return values. What are return values? They are essentially output to the function. I put the word output under return values because return values represent the output of the function. And down here in the code, everywhere I return something from this function, I underlined it. I'm returning a value here, I'm returning a value here, I'm returning a value here, and I'm returning a value here. Let's start this code example with some initial values in the variables. So follow this line over to here, and health is going to start with the value 93, and armor is going to start with the value of 55. Damage will start with a value of 8.0. Those are the values in my current variables as I call this function calc damage. There's the call to calc damage. Armor contains 55. So 55 will be sent as the argument, and p-armor will be set to the value 55. Damage has a current value of 8.0. 8.0 will be the value or argument sent to p-damage, and p-damage will get 8.0, and there's my value in my parameters. What is this? This is input to the function. The input to this function is 55 and 8.0. Inside the function, let's start executing the code. If p-armor is less than 10, that evaluates as 55 less than 10, and that is a false statement. What happens when a statement is false? We skip the indented code and we go to the else. In this case, this is an else if statement. Else if p-armor is less than 60, evaluates as 55 less than 60. 55 less than 60 is definitely a true statement, so what will happen is we will execute the indented code. We'll jump inside this code and execute it. Return p damage times 0.5. We have sort of a medium strength of armor, so we'll take half the given damage. The purpose of this function is to calculate the damage when the player of the video game gets hurt. Our main character has taken a shot, but if they have lots of armor on, we want very little damage to occur. If they have no armor on, we want full damage to occur. And in this particular case, with our armor value set to 55, that's sort of a medium level of armor, we will take half damage. What normally would be 8 points of damage, we'll multiply that by 0.5 and calculate a new damage value of 4.0. What happens to that 4.0 is it gets returned to the caller. Calc damage's job is to calculate the final damage value and send that back to the caller. It gets returned 4.0 gets returned to calc damage, and now we're able to calculate the impact that the hit took on the player in the video game. 93.0 was my initial value from health. I took a shot, I took some damage. Given the current armor value, it was calculated that I should take 4 health points off of my health score. And the new value of 89 is calculated. Does that make sense? When you're a player in the video game and you take some damage, you take a shot, you should take more damage if you have less armor. You should take less damage if you have more armor. With 50% armor, we're taking about half the damage we'd normally take. We calculate the 89 as the new health value and assign it to the health variable, and you could see that the health variable was updated to 89. What's the advantage of doing this in a function? Well, the advantage of doing this in a function is we don't have hundreds of different places in the code where a player is taking a shot and we're having to do this calculation in this if statement all over every place. We can put the code in one spot. We can easily update it if we ever want to change it. And we don't have to worry about maintaining 100 different copies of this same if-else statement. Let's do it again to show you how it calculates different damage based on different armor. Run again with new values in the variables. We'll now have an armor value of 92. Apparently, we've picked up more armor along the way, so we should be better protected against damage. We have a current damage assessment of 10. This 10.0 in damage is the strength of the shot that the player has taken. This is the full subtraction to the health value if we had no armor. But since we're doing this in a function, let's see how the function handles the new value with the new armor. Once again, we'll pass armor as the argument. We'll take the 92 and assign it to the parameter, and there's the assignment of the argument to the parameter p-armor. We have a damage assessment of 10.0. This would be full damage if we had no armor, and we'll assign that to p-damage, our parameter 10.0. Inside the function, we'll do the first if statement. If p-armor is less than 10, well, that's very false. We have lots of armor. That is a false statement. We'll skip past it to the next line of code. We're now at the else if p-armor is less than 60. 92 less than 60 is a very, very false statement. We will not, I repeat, we will not be taking that amount of damage. Next up, we have an else if p-armor is less than 95. Well, that evaluates as 92 less than 95, and that is a very true statement. When we get a true statement on the if, what do? We go inside and execute the indented code. And how do we do that? We p-damage times 0.1. Turns out 92 is a lot of armor. Our player is well protected. As a well-protected player, it should take very little damage. So we take p damage, multiply it by 0.1, or just 10% of the damage. 10.0 times 0.1 is 1.0. So a shot that would normally subtract 10 points from our health score should only subtract 1 point from our health score because we are fully armored. With that smaller amount of damage, our current health of 89 minus the return value of 1.0 says our new health value should be 88. After the calculation is done, we assign 88 to the health variable, and we have a new health variable. You getting the picture? Functions are very useful. I don't want to be calculating damage and armor and worrying about all of that stuff in 100 spots of my code. During a video game, especially a game of fighting, there's going to be lots of places where the health score and the damage score and the armor, they go up and down, up and down. You don't want to constantly be repeating the same code. You write it once in one spot, and whenever you need to calculate how much damage occurred, you call that one function. Therefore, if you ever want to update it or change it, you only have to change the code in one spot. Next up, global versus local. We've talked about these before. We have global variables and we have local variables, and there are differences between the two. Let's do a slide that explains the differences as it happens with functions. Global variables are the ones that are created outside of a function, and local variables are the ones that are created inside a function. X position equals 0, Y position equals 0. This is the global position on the x-axis. This is the global position on the y-axis. These are clearly created outside of a function, hopefully at the top of your code. You can create variables down farther in the code, but I like to put my global variables at the top of my code. A big reason for putting your global variables at the top of your code is so you can find them. If you start spreading them out all through the code, it's very difficult to find your global variables. Create your global variables at the top of the code outside of a function. What about local variables? Local variables are created inside of a function. xdiff, the parameter, is created inside this function. xdiff, the parameter, is a local variable. xnew here is also created inside of movex. Both of these variables are part of and local to the movex function. ydiff is a parameter to move y. Technically, it is created inside the function. It's local to move y. ynew is clearly created inside of move y. It is a local variable to move y. ynew and ydiff are local variables to move y. They are owned and controlled by the function move y. Let's execute some code. Let's run the method with initial values in the variables. Let's go ahead and set x position to 5 and y position to 580. These are the values in the global variables. One of the things you'll notice about the global variables is they stick around. These two variables were created as soon as the program was run, and they will stick around as long as this code is executing. I was running out of room here, so I put the call to move X a little bit farther to the right. This is code that would normally be down here below move Y. But I didn't have room down there, so I moved it over here. But assume this is after the functions are defined, because you cannot call a function until it's defined. This code has to be below the function defines. Call move X. Let's pass the argument -8 to the function, and -8 will be assigned to the parameter xdiff. You'll see that the -8 just popped up. This variable, because it's local, wasn't created until the function was called. Now it's created, and now it has a value of -8. Global x position says if we modify x position, we want to use this variable up here. Grab the contents from the global variable 5, add to it xdiff, which is the local -8, and calculate the new x position as -3. Take that -3 and assign it to our local variable xnew. The reason why we're assigning it to a local variable is because we don't know if that value is good. We could try to move the player off the edge of the screen, and we really don't want to move the player off the edge of the screen. What we're going to do is, before we assign it to the global, verify that we have a decent value in that variable. What I'm doing here is simply a check, a validate of the new position. If xnew is greater than or equal to 0 and xnew is less than 800, this evaluates as -3 greater than 0, which is false, and -3 less than 800, which is true. Well, false and true is a false statement overall. This if statement is a false if statement. What does that mean? It means skip the indented code. What we're doing here is we're seeing if we have a good value for the x coordinate. Apparently, we want to keep the x coordinate between 0 and 800. Many screens are 800 by 600 resolution. If we are off the edge of the screen, we do not want to change xnew. So this is good code that verifies that the new position is valid. And if it isn't valid, it skips the update of the global variable. It says, no, I won't allow you to take the character off the edge of the screen. We want to stay on the screen. Let's not update x position. This is the end of the function. How do I know it's the end of the function? Because it's the end of the indented code. What this will do is return from movex without updating the x position global variable. We went through that for nothing. Why did we do that for nothing? Because we tried to move the character off the screen. The code in this game will not allow you to move X position less than 0, so you're out of luck. It rather stop the character at the edge of the screen than move it off the edge of the screen. Move X is done. Notice also that the local variables were deleted. Local variables are created and deleted on demand. When you call move X, the locals are created. When you leave move X, the locals are deleted. What sticks around? The global variables stick around. Global variables do not disappear between function calls, but local variables do. Let's call move Y and look at the values in the global variables. They're still there. It's still 5 and 580 for X position and Y position. Global variables stick around. And this call to move Y happens below the functions because you cannot call a function until you define it. We'll call move Y and we'll pass it the argument 5. So we pass the argument 5 and ydiff, the parameter, gets set to the argument value of 5, and you can see it shows up there in the local variable. Inside the code, we declare a global Y position. What are we doing here? We're saying if we update the Y position variable, we want to go ahead and use this global version. Do not create a local copy of Y position. Use the global variable Y position, and you can see the 580 comes out of that global variable and provides the first argument to the addition. And then we add to it the parameter ydiff, which is 5, and we get a new value of 585. That 585 is assigned to the local variable ynew. Now look at that local variable. It has a new value, 585 in it. It looks like we're going to test that to see if it's good. On the next line of code, we have an if statement. If ynew is greater than or equal to 0 and ynew is less than 600. We want to keep ynew between 0 and 600. If it's between 0 and 600, we're happy with it. This happens to be a true statement. 585 greater than or equal to 0 is true, and 585 less than 600 is a true statement. True and true evaluates to true, so this is a true if statement. What does that mean? Execute the indented code. And the indented code happens to update the global variable. Y position equals ynew is going to change the value of the global variable and allow the character to move to that new position. It is a valid position in our 800 by 600 screen, so we will change the Y position to 585. And of course, we've reached the end of the function. Why? Because there's no more indented code. Everything that's indented below the definition will execute, and when you've run out of indented code, you're done with the function. It's time to return. And in fact, it will return all the way to the line of code after the call to move Y. Also notice at the end of the functions, what happened to my local variables? They disappeared. That's the definition of a local variable. It gets created when the function is called. It gets deleted when the function returns. There are three major differences when it comes to global versus local variables. Number one, globals are created outside of a function, hopefully at the top of your code. Locals are created inside of functions. Notice that these global variables up here are created outside of the function at the top of the code. Notice that these local variables here are created inside the function. Parameters happen to be local variables. Here's another local variable. Inside the function it is created, it is a local variable. The second major difference between globals and locals is global scope for all functions, locals only its own function. Turns out I can use these global variables in any function in my program. Hopefully I use this global keyword to say I'm using the global variable, but if I had 50 functions, I could use these two variables in all 50 of my functions. Notice that the global X position, Y position may be used in any function. It's used in move X, it's used in move Y. Use the keyword global, and you can use these global variables in any function you want. However, notice that xnew and xdiff are only used in move X. Local variables are only used in their own functions. Ynew and ydiff are only used in move y. Local variables are only used in their own function. The third major difference between global and local variables is what's called the lifetime. The lifetime of the global variable is as long as the program is running. These variables, the globals, get created as soon as you run the program, and they stick around. They stay there. Locals are created and deleted when the function is run. A local does not exist until you run the function, and it disappears when the function is done. Now that we're starting to write our own functions, it's an important decision. When do I use a global? When do I use a local? Number one, globals should not be overused. A program should have a small, distinct set of global variables. Only the most important variables should be declared global in a program. Local variables should always be used for things that hold temporary values. If you're not going to use it a lot or not going to use it in other functions, do declare it a local. It's a bad mistake to open up a program and see 1,000 global variables. It's just too many. The more global variables you have, the harder it is to maintain the code. So try to limit the use of globals. Save them for the most important values, like the X and Y position of a character on the screen. Pass by value. Make a copy. This is passing a parameter. There are two ways to pass a parameter. Pass by value, which says make a copy of it, and pass by reference. On this slide, we'll look at pass by value. We'll save pass by reference for a future lesson. Pass by value is also known as call by value. It essentially says the parameter is a copy of whatever you sent it. I'll set up a global variable here called money. Money will start with 20.0 in it, and you can see my global variable money has a 20.0 in its RAM memory. Notice how I jumped over the function definition. I jumped to the next executable line of code, which is not the function, and I do a print statement, money before, and I output the 20.0 from the global variable. This code executes from the main page or another function. The next line of code that executes is display money. This is the call to the function. Display money and pass it the global variable as the argument. This will be done pass by value, which means cache will get a copy of the money variable. It will not be the actual money variable being transferred as a parameter. It will be a copy of the value in the money variable that is passed. So cache will be set equal to 20.0. Cache is a copy of money. Passed by value means this is a separate and distinct piece of computer memory. It is a copy of that argument money. We'll print cache on hand. So we did send the 20.0 as an argument to the function, and we will print the copy of the variable cache. And you can see the 20 is coming from the copy variable right there. Now we're going to do something strange. I kind of forced this line of code in here. I wouldn't normally do this, but I want to show you what pass by value means, and I need to change the value of cache. So I'm going to say cache equals 0.0. But what you have to understand with pass by value, also known as call by value, is you will be changing the copy of the variable, not the original money. So cache will go to 0.0. What doesn't change in pass by value? The original parameter. I sent it money, but it got a copy of money, so I'm changing the copy, not the original. This is important because when I return, my money variable will be intact. Watch what happens to the copy when display money is done. So I've reached the end of display money. I've run out of indented code to run, so I'm going to jump back, but watch what happens over here to the cache variable when I return. When I get back from display money, the copy cache has disappeared. That's pass by value. Cache is a local variable. It gets deleted. The thing that changed values to 0.0 is gone. What has not changed? The original variable has not changed. The value in money is still 20.0, and the value of money still is intact. This is an important safety feature to Python. When you send simple variables, ints, floats, strings, two functions. They are pass by value or call by value. It means that Python will make a copy of that variable, and anything you do to change the parameter will not affect the original parameter. You can pass a parameter with no worries that this value will change in it. That's for ints, floats, and strings, other simple types. When we get to more complicated types, we'll do something different. Pass by value, the parameter is a copy of the variable passed to the function. There is no change to the original. If you pass by value, money contained 20 before the call, money will contain 20 after the call. Data types like int, float, and str or string are passed by value. No changes will occur to the parameter money. No changes will occur to the argument money if you change the parameter when it's passed by value. The alternative to pass by value is called pass by reference. That's when the parameter is not a copy of the variable passed. In pass by reference, you can change the original. Now, I didn't show it here. We're not quite ready to study pass by reference, but when we get to more complex objects, they will be passed by reference. Especially more on pass by reference when we start to cover objects and object-oriented programming. All right, so we saw, 4 different functions there. It's important to get good at writing functions. A constant theme in any computer science class is to break large problems into smaller problems. And that's the whole point of a function, is to break up a larger problem into smaller problems. The second major thing about a function is write once, use many times. We want to be able to write a function once and use it from many different places in our code. Globals versus parameters. Quite often as a program designer, you have a choice. Do I use a global variable in the code here, or do I use a parameter to a function in the code here? The purpose of this slide is to explore the differences between using global variables to pass information to a function and using parameters and return values to pass information into and out of a function. When writing a function, for input and output, you have two choices. A, or option A, is use parameters and return values. Parameters for the input and return value for the output. The other option, the alternative to parameters and return value, is to use a global variable. You can put a value in a global variable, call the function, and it becomes input. You can change the value of a global variable, return from the function, and it becomes output from the function. So those are your two choices. When it comes time to designing a function, you can use parameters and return values, or you could use global variables for input and output to the function. Now, I set up a global variable called level. Now, that's certainly an important enough variable to be a global. You write a game, it has 10 levels. As the player finishes level 1, they go to level 2. As they finish level 2, they go to level 3. That is an extremely important variable. It meets the test of a global variable. It's extremely important we keep it as a global variable. But let's look at both ways that we can change that global variable, especially as we call functions. Option A, as I explained earlier, is we can use parameters as input to a function. I'm going to write a function here named bump level, and bump level is going to have a parameter which will be the input to the function. Well, at the time this code executes, the global variable level contains a 1, so it will pass the argument 1 to the parameter lev, and lev will be assigned a 1. We are passing a parameter as input to the function. With that parameter, we can execute a lev equals lev plus 1, and the copy passed by value, lev is passed by value, the copy changes to 2. Now these are two separate variables. Level is a global, lev is a local. We're changing the copy to 2. We will then return lev. Option A for output was to send the return value back as a return value as output from the method. So we are going to send the value 2 that is in this local variable back to the caller as output from the function. And what do we do with it when we get back? We assign it to the global variable level. The 2 that was returned gets assigned to the global variable, and you can see it right there. A 2 shows up in our global variable. This was option A. Use parameters and return values as input and output. It ended up being the global variable that was passed as input, and it ended up being the global variable that got updated with the return value. But during the execution of this function, we never touched the global variable. We used the parameter and return value for input and output. Don't always have to do it that way. There is a different option. There is a different way to call a function. We wrote a second function called bump level G. Well, what does bump level G mean? It means bump level global. This time, instead of using a parameter and a return value as input and output, what am I going to do? I'm going to take option B. Option B said use current global variable value of 2 as the input precondition. Instead of passing a parameter to this function, level G is going to go ahead and use this global variable as input. The global variable currently contains a 2, so that 2 ends up being the input to this function. The 2 from the global variable gets 1 added to it, and a 3 is calculated. Option B says level 2 set before the method is called. That was input to the function. The 2 in the global variable was the input to the function. We calculate the 3 and assign the 3 back into the global variable. Option B was global level is set to 3 after the call. This is the output from the function. It's also called a post condition from the function. Before this function was called, we had a 2 in this variable. That was input. After this function is called, we have a 3 in this variable. That is output. When we return from bump level G, we have updated the global variable. Both of these two lines of code do the same thing. This had a 1 as an input and an output of 2 and updated the global variable. This one just directly changed the global variables without having to do a parameter and return type. So before the call, level was 2. That was input to bump level G. After the call, level was 3. That was the output of the function. When writing a function, you always have two options for input and output. Option A is to use parameters and return values for input and output. Option B is to use global variables. Now, which one's better? Number one, parameters and return values is considered a better programming practice. If you can, it's probably better to use parameters and return values than global variables. Number two, use globals sparingly. Too many is too much. For those things that get used in a lot of functions, it's okay to use a global variable. Level is a good example. Level is accessed many different places. You don't want to pass it to 1,000 different functions, so maybe level is okay for using global variables. But once again, when it comes to globals, you don't want to overuse it. If you find yourself using 1,000 different global variables instead of parameters, you're overdoing it. Globals are for the things that are most important. The player's score, the player's level, the player's health. Don't overuse global variables. Try to use parameters and return values instead of global variables. Number three, experience is the best teacher. Beginner programmers, they just have to learn. The more you write code, the more you'll understand when you want to use global variables and when you want to use parameters and return values. Good luck. That's it for this lesson. We'll see you on the next lesson. Have a good day.